Since 1990, the Hubble Space Telescope and other space telescopes have allowed us to look deeper into time and space than we ever have before. In several deep sky surveys, the Hubble Space Telescope has visualized an area of the sky the equivalent of the width of a dime held 75 feet away. In these surveys, over 1,500 galaxies are visible. Each of these galaxies may contain between 100 billion and 400 billion stars. The light from these galaxies is not equal. Some of these galaxies are very far away, and the light has taken 12 to 14 billion years to reach us. This means that what we see is not the galaxy as it is today, but as it was just after the Big Bang and the formation of the universe. Our own galaxy, the Milky Way, is a spiral galaxy similar to those shown here. Galaxies, like individual stars and planets, are perturbed by each other's gravity. Hubble has seen the interactions between galaxies that spiral in toward each other and sometimes merge, forming larger galaxies. Hubble has also revealed great stellar nurseries where new stars are born. These nurseries, called nebulae, originate as dust and gas, much of which was left over from the Big Bang. Other parts are leftovers from the remnants of previous generations of stars. This dust and gas collapses under its own gravity, falling inward until a body dense enough to ignite the fires of fusion becomes a new star. Throughout the universe, new stars are born, they age, and they die. The remnants of dead stars are then recycled into new stars and planets. The largest stars have the shortest lives, and also the most violent endings. A large star ends its life as a supernova, one of the most violent events in the universe. All of the elements heavier than iron, including such precious metals as silver, gold, and platinum, were formed in supernovae. Medium-sized stars cast off their outer layers when they die, forming planetary nebulae. These nebulae enclose the entire dying star, but when viewed through a telescope, take on this ring-like appearance. Our own Sun will probably do this in about 5 billion years. The material in the planetary nebulae eventually will be recycled into new stars and new planets, and thus continue the life cycle of the stars. Planets are thought to form from the remaining gas and dust left over from when a star forms. The Hubble Space Telescope has imaged several such protoplanetary disks around newly formed stars. In one case, Hubble caught an image of what appears to be a protoplanet being ejected from its solar system. Our solar system contains 9 planets and myriad other smaller bodies like moons, asteroids, and comets. Astronomers have looked around other stars and found evidence for over 100 other planets outside of our solar system. So far, all of these planets have been much like Jupiter, very large and made of gas. Earth-like planets would be very difficult, if not impossible, to find using current technology. Newer space-based telescopes will be needed to find anything like Earth around another star. The Kepler mission, scheduled for launch in 2007, will be the first of these new telescopes to hunt for Earth-like worlds. Kepler will search for other planets by measuring the apparent dimming of the star as the planet moves between the star and Kepler's instruments. At the same time, Kepler's instruments may be able to measure the planet's atmosphere, which in turn will tell us whether or not that planet could sustain life as we know it. Ultimately, we would like to answer the big question: are we alone in the universe? Or do other worlds like ours exist, with living creatures curious about the universe, just as we are?